Hi everyone. I thought I'd make a quick video tonight to go over a few of the problems that are showing up on the review for Unit 2. These are some of the questions that I had the most questions on in class that I was seeing a lot of little mistakes on that I thought would be good to kind of recap. So anyone who is able to watch this before they do their test, hopefully that'll help clear up a few things that were going on. So the first question I want to take a look at is number 3. In this particular problem, you are asked to do the composition of f of g of x, given the function f of x, which is x squared minus 5, and the function g of x, which is x plus 2. Since g is in the inside of the parentheses, what this question is asking you to do is to take the x plus 2 for the g function and actually come over and substitute that in for x in the f function. So what this is going to look like is x plus 2. This part is going to be squared, and then the minus 5 comes after it. So the x plus 2 is coming from the g function. What a lot of misconceptions are then is what to do with the x plus 2 squared. And again, remember, this is a binomial squared, so the easiest way to do it is to write this out. It's x plus 2 times x plus 2, and then minus 5. If you want to use your double distribution from here, you're going to take the first x and multiply it by the second set of parentheses. And then you would take the second value in that first binomial, which is a positive 2, and you're also going to multiply it by the second set of parentheses. And we still have the minus 5 hanging out at the end. If you do your distribution from here, you will get x squared plus 2x. In the second set, you're going to get another positive 2x, and then plus 4 with the minus 5. Cleaning this up, we will still have our x squared. The two x's are both positive, so they'll add up to a 4x. And a positive 4 to negative 5 will give me a negative 1. So this is the final answer to this problem. The next example that we're going to be taking a look at is the first question that asks you a lot more details about domain and range. So this is actually question number 10 from the review, so I'll put that over here. And I'm just going to go through a lot of the basic information here just to make sure that you know how to answer some of the questions that are here. So the first one that's here is to find the largest x-intercept, because a couple of them don't exactly come out very nice. So the largest one is going to be right here, and again, that means you have to give the x value that that crosses at. So this is going to be happening at 5. So you can either give the answer of 5, or if you gave the point of the actual intercept would be at 5, 0. The next thing that we're asked for is to identify the y-intercept. That's part B. Y-intercept, of course, is where the clear intersection of the y-axis is, and that happens at negative 1 or at the point 0, negative 1. From here, we need to do some work to identify our domain and range. So one of the suggestions, if you follow along with what was done on the homework, was to actually do a box around the function so that it's easier for you to identify where the function is going to begin and end. So this is one possibility for making it a little bit easier to identify your domain and range. Domain is going to be your x values. So you can represent the domain in two different ways. One way is to use your interval notation to show what the lowest value is to the highest. In this case, the lowest x value is going to be right here. That's at negative 1. The highest x value is actually at this position here, which is at a positive 6. And since both of these points are actually on the function itself, I would have to use square brackets to indicate that for the domain. The other way that you could indicate this is to actually write it as an inequality, both signs being less than or equal to, because those points actually exist. In order to do the range, we're basically going to do something very similar. The range of values is going to be your lowest y, which happens to also be the same point we were just looking at here. If you look at where that is, it comes at negative 2. The highest y value, though, is going to be your maximum over here, and if you trace that over, that's going to be at 5. And again, since these 2 points are actually on the function, I am going to put square brackets around them. Or you could choose to write it as an inequality. Just remember that since you are dealing with range, you do need to use y in your inequality, not x. I'm going to erase some of the information that's on here now, just so that way we can move on to the next part of this. The next part is going to ask whether or not the function is 1-to-1, so that's actually part E here. In order to identify if it's 1-to-1, you can do this in a variety of different ways, but the easiest way by far is to simply go through and verify whether or not the horizontal line test works or doesn't work. In this case, if the horizontal line intersects the function in more than one spot, then this is going to not be a 1-to-1 function. So because the horizontal line test does cross at least twice, sometimes more depending on where you drew it, this is no, and the only real explanation you really need for this is you could say that it fails the horizontal line test, or you could also identify that a y value has more than one x value. And that is the main thing to look at here. Another question that I was receiving was about asking whether or not the function was increasing and decreasing at different intervals, and there was some confusion over this. The easiest way to take care of the increasing and decreasing for this type of function is to identify where the turning points are. So if you take a look at what's really happening, the function starts at -1, so it starts at this location here, and then it will stop decreasing right here where there's a lower turning point. There's a minimum there. Then the function is going to increase until it gets to the next turning point, which happens at this position, and then the function will decrease again, stopping at the end. So what we have is an area where the function is decreasing, increasing, and decreasing again. So when you want to figure this information out, the decreasing happens over 2 different intervals. The decrease happens from -1 to 0, so you got to use the x values to determine where this is happening. And because this time we are actually talking about when the function is increasing or decreasing, we do not want to include the turning point values because it's not actually increasing or decreasing at those spots. The other decreasing interval is going to be from +3, which is where this turning point is up here, to +6, which is the lowest point down here. Again, we're looking at the x values when determining that. So 3 and 6. And sometimes you will see these with the symbol in the middle for union, saying it's these two combined is where the decreasing values are. As for increasing, that would be our interval in the middle, which is going from 0 to a +3. Again, we are only using parentheses because we do not include the values. The next thing we're going to then take a look at is going to be our relative and max mins. So let's just take a quick look at that. And I'm just going to label this information directly on the graph so that you can see exactly what we're talking about here. So in this particular example, the first thing I'm going to do is I'm going to identify the points where we have our max and mins in general. So one of them is going to be here because the function does have an endpoint at that position. We're going to consider that to be one of the maximum. And this point up here is also going to be considered a maximum. So right now, these are both relative maximums because they are both maximum turning points. This function also does have a couple relative minimums. One of them is going to occur right here at 0. And the other one is going to occur all the way here at the end, and that's at 6. Again, you're looking at the x values for where those occur. The last part of this problem, though, wants us to identify what the absolute max and min are, and the absolute max and min are simply going to be the highest of the maximums and the lowest of the minimums. So your absolute in this case is going to be over here at 3 for the maximum, and it's going to be at 6 for the minimum. So these are your absolutes, because they are the highest and lowest respectively. Finally, the last problem that we'll take a look at, actually number 12 off of this, just to make sure we can kind of see more of an application base. So we are looking at an actual graph that shows the changes in relative humidity during a 24-hour period in New York City. The first thing that this wants to know is whether or not this graph represents a function, and it should be pretty clear that yes, it does. And we can simply say because it passes the vertical line test. And if we go through and actually test it out, obviously there is no spot where we can draw a vertical line that it will pass through the function more than once. However, part B wants to know whether or not the graph is a one-to-one function, and this is definitely a no because it will fail the horizontal line test. And if you take a look, here's one example where it's going to pass through twice here. Here's another example where it's going to pass through twice. As soon as we find one of those, we know that we do not have a one-to-one function in this particular case. Finally, the last part about this is, again, going through and actually stating the domain and range. So we will do that again. And once again, if it's easier for you to go and make this rectangle around the function just so that it's a little bit more clear to see the values, you can always do that. And there we go, we got the whole thing covered. So our domain in this case is going to be all the x values. I'll leave this one in interval notation for now. The lowest x value is going to be right here at 0, and the highest x value is going to be all the way at this end of the graph, 24. And we are including those because we see solid points at those locations. So we can use square brackets, or if you did write it as an inequality, they would both be less than or equal to signs. And then finally, for the range, we are going to look for the lowest y value. The lowest y value is actually in this position. That's at 30. So we know we're going to start there. And then the highest y value is over here where we see a maximum, and that's at 80. And so that would be our range. And again, you can use less than or equal to signs and a y if you are going to write this using any type of inequality as opposed to the interval notation. So that's going to wrap up my quick little review on some of the questions that I had the most comments about or anything in class. If you have additional questions, you can always contact me through Twitter if there's anything else that you have to that you need some help with before you take this test. Good luck.